Today we'll be presenting our Capstone that MCIS sponsored a HIPAA compliant network that was set up for Stark Dental. My name is Luke Bednar. I'm the team lead for our group. This other professional looking people are...
I'm Tanner Matheson, server engineer.
I'm Crystal Evans, the wireless engineer.
And I'm Sam Trudeau, security engineer.
Alright, so today we're going to be breaking down our presentation into three phases. We have basically our first phase is going to be talking about our IP addressing, our topologies, and talking about what HIPAA compliance is. Second phase is going to be doing our demonstrations, talking about our servers, our NetScaler, our Palo Alto, and phase 3 will be talking about lessons learned and different troubleshooting techniques that we ran into.
So to start phase 1, let's look at the topology. You can see in red is our remote site, and in blue is our main site, as well as the logical representation of our DMZ. They both have internet connections with a DMVPN connection between the two sites, so they can work flawlessly together. You see the blue servers are ESXi boxes that host everything on the main site. These are all the services that are used, and then on the remote site we have the backup failover services. And in the DMZ there's two of our web services that are balanced loaded by the Citrix NetScaler, which we'll talk about later. To continue that, our IP addressing scheme splits up all the traffic for the NetScaler, for the server, subnet, and we have wireless traffic, guest wireless traffic. These are all split into subnets that use the same number as the VLAN for that traffic. And we use the third octet for that. You can see .5 is our server, .111 is our NetScaler, and so on and so forth.
So a large part of this project that MCIS gave us is HIPAA compliance. Now, HIPAA compliance is important because it is something that they have to deal with every single day. It's also very important because any sort of violation of HIPAA can cost in major penalties and fines, such as up to $1.5 million per violation. So HIPAA compliance is actually broken down into two rules. The privacy rule, which deals mostly with privacy standards. So it's a lot of administrative overhead, something that was kind of out of the scope of this project, but something to keep in mind while you're doing this project, is you're going to want to make policies for how users are created, how long your password has to be, so on and so forth. Those sort of policies. It also has the security rule, which sets security standards for the networking technicians, such as ourselves. So that is how your policies have to be configured, who you can authenticate, how they have to be authenticated, so on and so forth. And HIPAA compliance is actually only on networks that deal with protected health information, otherwise known as PHI.
Then on to phase 2, we're going to start off talking about our servers. We basically have one server or one domain controller in the headquarters, and one domain controller as a secondary in the remote site. And the few basic functions of these servers, they're running Active Directory, which is the central management of domain users, computers, and groups. It's necessary for running radius authentication for all the domain logins, for setting GPOs, the group policy objects, as well as setting file shares through GPOs. It's also running our DNS servers, which is used by the NetScaler, using conjunction with the NetScaler, and GSLB relies on DNS solely. And we are also running Certificate Authority, which is it's an entity that digitally signs certificates. It's basically the server is handing off a key to the network. People with this key can access different secure parts of the network. And then we're also, two-factor authentication is also using the Certificate Authority. And then one application that we're running is AppLocker. It's a Microsoft service basically that allows you to delegate the control of who can open certain apps within the network. So we have a bit of a demonstration on AppLocker. For proof of concept, we blocked a Microsoft application as well as a third-party application, Mozilla Firefox. So I'll show you how that works here. We'll just go over to our server. Go and log in. So this is the domain controller on our main site.
So as you can see, most of our services are running virtually on the VMware service that we have running. That's for all of our virtualization. We also have a vSphere client on here to manage all of our virtual machines as they're running. So once it all loads up, you should be able to see exactly what we have running on them. We have two main servers running we have one main domain controller and one backup domain controller on the main site, and we have a single domain controller on the remote site that acts as a backup in case of disaster recovery.
We're connected on our Wi-Fi right now. All the gears in the back room over there.
So it is a little slow to connect.
Here we go. Alright, here we go. So demonstration of AppLocker quickly. It'll show you that you cannot open Paint. It says it's blocked by your administrator there. As well as Firefox here. Cannot open it. Basically AppLocker runs. You can set multiple different ways to block applications. The way that we're doing it right now is blocking the .exe file. So you basically specify the path of where this exe file is, and you can either say allow or deny, and then assign permissions, whatever you want for that. It's really helpful for security because you're able to lock out certain applications that could be posing a security threat.
Awesome, and then continuing on with network security. So what we have configured on our network for network hardening is something that is part of Cisco's best practices. So we have DHCP snooping. Essentially all that DHCP snooping does, along with HIPAA compliance and Cisco best practices, is stops any rogue DHCP servers from any anonymous user that comes on your network and would want to steal something, some sort of PHI. They can set up a DHCP server and take your information from there. So that is how that relates to this network. We also have ARP inspection, which does something similar to that, but it also stops any sort of remote entity coming in and taking control of your network. We have ACLs to allow traffic from who can authenticate into our VPN, who can't, as well as where a user can go on our network and stop ICMP traffic from the outside coming in, because you don't want somebody mapping your network externally and then seeing everything you have on it. Another big security tool that MCIS gave us is the Palo Alto. So the Palo Alto is a zone-based firewall. You can configure traditional policies on it for your standard firewall use, but it also is a next-generation firewall. And the advantage that this brings is that you can block web applications through it. So blocking a web application is as simple as Palo Alto sends the applications to the firewall itself, so they're all built in, and you can select which web app that you want to block through that interface. And with that, I will show you this demonstration on how that actually works. So when you go into the Palo Alto, I'll just show you the rule real quick. So it's blocking Google Drive from any zone, coming from any zone to any zone, and it's a deny. So we will go to Google Drive right now. Now, when you Google Drive, you don't always get sent right to the Google Drive page. You get sent to the splash page. But essentially, oh, nice. Pick's right now to work. Oh yeah, wait. Huh. Well, that's nice. Alright. Well. Yeah. So now we'll actually go from the server, because for some reason it picks right now, it'll start working. So from here, when you're on the domain network, you will not be able to access Google Drive. So let's go to this one. Here. I actually just tested this 5 minutes ago and it worked. So don't know what happened in that small span of time. But now go here. Go here. Go here, and you should be blocked. Alright, it's asking for a sign in, but if it gets you to that point, you cannot access it even after you sign in. It'll get you to that point. So from there, that is the power of the Palo Alto, and you can also block specific URL applications, as well as it is running the VPN service that we will be using during the presentation.
So the next equipment we have is a Citrix NetScaler that our sponsors gave to us. So it's basically a physical appliance, or you can host it virtually on the EXI box. So the kind of feature that it has load balancing, and a really unique feature that it has is server health monitoring. So this works with the global service load balancing. So basically the server health monitoring says, like, if something's wrong with the global load balancing, it will pick up on that, and it will actually adjust the traffic for that and fix the global load balancing. Another thing that the NetScaler can do is it can perform authentication using the NetScaler gateway.
These are all features that we implemented in the Stark Dental network. Obviously, a lot more than Citrix NetScaler is capable of.
Alright, and then two-factor authentication, that's a growing thing, and basically two-factor it's just saying that you are you. So it's just adding another layer of security. So for the authentication method that we are using, we are using the client certificate that's just basically saying that your computer is trusted. And then we are using LDAP as well. That just runs with Active Directory, so that's another layer of security. And this runs on the NetScaler Unified Gateway, and I'm going to show you the demonstration for this. Alright, so here's the gateway.
So right now we have the LDAP users set up for this login. We're still working on some kinks on the certificate, second factor. So that was an Active Directory user that we logged in.
Yep, and a nice thing is that if your company wants to, they can add different application to this page, and you can even add like your company's website. And another unique thing.
So another use case for NetScaler that we have on our network is the GSLB, which is Global Server Load Balancing. So here's a kind of logical workflow of how NetScaler does this. The computers and users connecting to the service that you want to load balance. Think it just looks to them like they're connecting to that one service, when really it's connecting to the NetScaler, which has these virtual services running in the background, so that you can load balance several of these services that look like one service. I can show you a demonstration here. Hopefully DNS is set up right. So here's a web page with a green background. Add this one DNS resolved friendly name. So if we load this, it's set up to round robin to the other service, which has a white background, so you can tell we're going back and forth between them. So that's the load balancing part. Now if we were to go onto one of those, so there's two servers hosting this web page, and if we go on this one and turn off that service, we will seamlessly continue to access this service, but only have one background color now. Still up. Now if we go back here, start this service. It'll take like 20 seconds, but it'll pick up. It's also set up on NetScaler to use geolocation, so you can, there we go, it's back. So if we are connecting in from somewhere else in the world that's not very close to your services, and you have services elsewhere, you can set up your NetScaler to send that to a closer location and balance between those services that might not be on the same site. So to continue on to the failover, we also have a set between the two sites DHCP failover. So if the main site DC goes down, the remote site takes over, and you can still have DHCP working everywhere. That's set up. Took some configuration on the network, on the DCs, and also one key part of that is to make sure you have your options. If you have any extra options that you have to add that are personalized, like we had option 43 for some access points, you have to configure that before you replicate them over, otherwise those subnets won't replicate. And we have HSRP set up on network devices. And you know, the last one.
Yeah, yep. So we also have replication going on our domain controllers. Like Luke said, that if one domain controller goes down or the connection is severed, the other domain controller will pick up. So the other domain controller can still handle all the network logins, as well as DNS records as well, to keep the other site up and running.
Talked a little bit about geolocation already.
And then another cool thing about the Palo Alto too is the VPN service that we have running. It is able to block a user based on their geolocation. So either they have to be within the United States, within a certain country, within a certain state. It all does it by analyzing the public IP that it uses.
So next we'll talk about some troubleshooting that we had to deal with during the course of this project.
So the Palo Alto is actually a big piece that we had to troubleshoot a lot. Luke and I actually spent a lot of time troubleshooting the network connectivity issues we had between the router and the Palo Alto through the OSPF areas. The routes weren't being redistributed correctly between our EAGRP protocol and the OSPF protocol, so we spent a lot of time doing that as well.
Justin probably remembers the NetScaler troubleshooting we did. Had to get into the CLI just because some confusion in working with the NetScaler that's pretty new to us. So we ended up just getting a better understanding of how the CLI works and how Citrix does their networking. Figured that out with some help.
I had to do some troubleshooting with our security baseline. I really broke dang near everything on our server to the point where you couldn't open up the start button anymore. You could only control Alt Delete to get to Task Manager. It was a mess. So I ended up having to boot into safe mode, running a few extra EXEs to undo what I did, and then booting back to normal to run it the right way. Install packages in the right order this time.
So our array configuration, so we had basically got our servers up and running, and then we noticed that we couldn't see any of our storage, and we were pulling out the hard drives, and we were like, okay, what's up? So we talked to our sponsors, and they're like, well, it could probably be a RAID thing, and once we configured that, we got our storage back. Now it's just up and running.
It's kind of like a boot into a GUI like a BIOS. You can use a mouse for that. We only had a keyboard. It wasn't working for some reason with the mouse. Yeah, we got great configured on that.
Some lesson learned is that using a step-by-step guide is not always the answer. With me, I learned that watching the videos and noticing the things, how do I say it? Just noticing the little things that were added in the videos that weren't added in the actual configuration, so that helped me out.
To go along with that, just learning the terminology of something that you're working on, and just understanding how it works before you start trying a configuration or trying to teach yourself. It's very helpful in the learning process.
One thing that I thought was really important was how good our SharePoint site was. First thing we did when we first got our teams, we set up a nice SharePoint. It was so easy to share documents with each other. We always had access, even if something was, saved locally on somebody else's computer, you just message them quick, hey, throw that up on the SharePoint, and it was access for everybody.
Then the last piece, something that I learned, is that communication is key with your teammates, with your sponsors, with whoever you're doing this with. Communication is the biggest part of this project, is you're all working together to the same end goal.
And I just want to say thank you for watching our presentation, and I just want to open up for any questions.
I'll see you Friday.
Yep.